Hi mathematicians, here we go. I have a quick little video where I'm going to be doing the odds for the examples, and then your homework will be to do the evens on your own. And you can see at the bottom of your paper that the answers are provided. Now there's no room to do it on here, so you need to get lined paper, and I'm just going to get going on this example 1. So we're solving equations with square roots. I actually think we did this at the beginning of the year, but it's a good review before we get to these exponents that are fractions. Okay, so the first thing we need to do is get the square root by itself. Isolate the square root or the radical. So we're going to add 7. Now what's 2 plus 7? It's going to be 9. Don't lose your equal sign, okay? Make sure you keep that equal sign. Now that the square root or the radical is by itself, we can get rid of it by squaring both sides. And then we have what's 9 squared. 9 squared we know is 81. And then it gets rid of the square root, so we're just left with what's inside. And then we're going to find x. That's our goal. Remember that? Remember solving for x? Here we are. Back again. It says 80 times x, so we're going to divide by 80 to get 80 divided by 80 equals 1, x equals 1, and we should plug it in to check. I'm not going to have time on the video to check every single answer, but 80 times 1 would be 80 plus 1 is 81. The square root of 81 is 9, and negative 7 plus 9 equals 2, so we're good. Okay, let's do number 2. Nope, not number 2. We're going to do number 3, because I said we're going to do the odds. Here we go. Now in the previous one, we added 7 to the other side, but here this 6 is attached by multiplication. So we're going to divide to move it to the other side. So do you see here that said negative 7 plus the square root? We had to add it. Here we need to divide, because 6 divided by 6 is 1. Okay, what do we have on the left? 30 divided by 6 is 5. Here we go. Now we're going to square both sides. 5 squared is 25, and that just gets rid of the radical, and we're left with what's inside. All right, solve for x. Undo, or inverse operations. This should feel really good. You're like a sophomore or a junior by now. This was hard when you were 8th grade or freshman, and now you should be like, oh, feels good to solve for x again. Okay, moving along. Doing good on time. All right, on number 5, we have a square root equal to a square root. So if you think, how do I undo a square root? What's the inverse of a square root? Well, it's to square both sides. Well, what happens when you square both sides? Both square roots cancel, and you're left with k divided by 2. You're left with just the inside equals the inside. Okay. If k is being divided, there's a couple different ways to do this, but if k is being divided by 2, I can multiply by 2. But just make sure you multiply everything by 2. Okay, careful. This was, we were squaring, and this we're multiplying by 2, which is not the same. All right, 2 divided by 2, divide out, and we get k equals 60 minus 2k. And I think I'm going to add this 2k over here. And 2k plus k is 3k. Equals 60, so 3 times what is 60? 3 times 20. Okay, and we're going quick, but we can always go down and check that 5 was 20. Awesome. On to 7, same thing. We have a square root, equal to a square root, which means when we square both sides, they go away, and we're just going to put the inside equal to each other and solve for x. How do I want to solve for x? Let's move these 3 x's. Very loud announcements on right now. -3. Check. Check. Okay. Okay, that was just our warm-up. Those were should have been pretty easy, but now on number 9, when we want to square to get rid of this square root, we can't just square each term. We have to go like this, y'all. You have to square the binomial. Now, we've been practicing, we have seen this in the last few weeks, that this multiplies out to get x squared minus 6x plus 9. And then that will equal the inside of the square root. Okay, now we have a quadratic, and what do you have to do with your quadratics? You have to set them equal to 0 in order to attempt to factor. So because of this x squared, I'm going to move these terms over to the left side. It won't always be the left, but I just saw that x squared is set up here. So I'm going to move everything over here. Okay, now that we have it equal to 0, we're going to try and factor. Not everything can be factored, but we always like to try. Now what multiplies to get 16, but adds to get -8? Looks like that, yeah? And so we only have one answer of x equals 4, and we should plug that in to check. I'm going to keep going though, because we are not even at the hard ones yet. Okay, how do we get rid of the square root? Square. Now I know you want, that's lame-o, x minus 3. We just did x minus 3. I wish you would have gotten a different example there, but that's okay. Okay, the square cancels the square root, and now we're going to FOIL this out. X times x, x times -3, x times -3, and then -3 times -3. I just showed the work, whereas I did it faster here. All quadratic, it's a quadratic. It's going to be set equal to 0, and I like where this x squared is, so I'm going to move everything to the right-hand side. Okay, so if I add 1x, okay, watch this. We had -6, but I'm adding 1. So -6 plus 1. And then I had the number 9, but we're going to subtract 3. So what's 9 minus 3? +6, yeah. And that's equal to 0 now. Oh, the 5 and 6's. Do you get those mixed up? We need it to multiply to get 6, and it has to have the same sign, but it needs to add to get -5. So same sign, multiplies to 6, 1 and 6, or 2 and 3. It's going to be 2 and 3 because the signs were the same, which means x equals 2 and x equals 3. But, you ready? There's a big old but on this one. We have to check these answers because we might have an extraneous solution. So if you plug in 2 to the original, you get square root of -2 plus 3, which is 1. But on this side, you get 2 minus 3, which is -1. So does 1 equal -1? No. So this is called an extraneous solution. Remember that? So the only solution is 3. If you plug in 3, you get 0 equals 0. Okay, now to the good stuff. You ready? How do we solve these? I'm going to pause and write down some notes, okay? Okay, step 1 is to isolate your base. And then you can do this in 2 steps by undoing the root and then undoing the power, or you can raise both sides to the reciprocal power, and I will explain. I have number 13. My base is v. I need to get the base by itself, so I need to move this 3. So how do we move the 3 to the other side? We're going to subtract it. And what's 11 minus 3? 8. We like 8. We've seen 8 a lot. So I have v to the 3/5 equals 8. Okay? You can undo the root by raising both sides to the power of 5, but I don't know what 8 to the 5 is. So I'm actually going to just show you this step here, okay? I'm going to raise both sides to the power of 5/3, the reciprocal power. Now, power of a power, this equals v to the 1. So v equals, and then we just need to evaluate this, which we've been practicing, right? What's the cube root of 8? So the cube root of 8 is 2, and then 2 to the power of 5. Is that 32? I forgot, but I'm pretty sure. Yes, it is. Okay, good. That's it. Let's do it again. More examples, as many as I can get in the 15 minutes. So we need to isolate the base and then raise both sides to the reciprocal power. Now, this is a crazy one. Our base is isolated, so I'm going to start by raising both sides to the reciprocal power. Oh my gosh, sorry the lights go out. So the reciprocal of 5/3 is 3/5, and then those cancel. And over here we have 3/5. Is that what I said? Okay, what's the 5th root of 3,125? I don't know, you guys. Some of them are just too big. I think it's 5, so I'm going to check. I'm going to say 5 to the power of 5. Is that 3,000? Yay! 3,125. So I was right with my guess, but you can use calculators. It's okay. So the 5th root of that is 5. Oh, I forgot. We still have this. Yeah, we're not done yet. And then 5 to the power of 3 is 125. But we still have to solve for a. But the power's gone, right? So now we just subtract 17 and divide by 6. 125 minus 17. I don't feel like doing this right now. Do you ever do that? Oh my gosh, this is embarrassing. We have an 8. 108. What do you guys think? I think so. Now we're going to divide this by 6. Should I go to the calculator? When was the last time you did this? Should we do this? 1 times 6. Oh my gosh, look at that. 6 goes into 48. I think that's 8 times. What do we think? We think 18. A is 18. Look at that. Oh, isn't it nice? Isn't it fun when you get the right answer? All right, I need a new piece of paper. Hang on. Okay, 2 minutes. Can I do 4 in 2 minutes? What's the goal of this? Reciprocal power. Say reciprocal power. Reciprocal power. Now, the cube root of 8 is 2. So we have 2 cubed will equal this wonderful inside. So 4 equals -1 minus n. Watch this. I'm going to add 1. Add 1 to both sides. So I get 5 equals -n, which means what does n equal? N equals -5. Okay? Keep going. 19. Reciprocal power. Reciprocal power. These are kind of more simple than the first few. Whoops, whoops, whoops. I did it wrong. I forgot the reciprocal. Okay. Reciprocal power. Hi-ya, 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 hi-ya. Karate chop, and we just get x equals, now what's the 5th root of 32? The 5th root of 32 is 2, and then 2 cubed is 8. So x should equal 8. I'm going to go back and check when I have time. I'm rushing. Okay, isolate the base. Do you see how it says m plus 10? So we have to subtract 10. What's 14 minus 10? 4. I'm not showing all the work I did at the beginning of the video. Now we're going to do reciprocal power, reciprocal power. This just looks like 4 cubed, right? 3 divided by 1 is 3. So I have 4 to the power of 3. 4 times 4 times 4. I think that's 64. You know, it's Friday. I'm ready for the weekend. And let's try this one. Okay, we have a negative. I'm going to pause and show all the work. So even though it's negative, you take the reciprocal power. Now, it was 1/4 to the negative exponent, so it moved the 4 up and made it positive. When you take the square root, though, we need a positive and a negative 2. Do you see that? So we'll have two answers.